So, we throughout the day we have spoken about new technologies, consumer demand, trends, alternative fuel, regulations, policies. It all brings down and boils down to one important crucial step: testing and validation. Without testing the right product, without doing the right testing and validating it, you can only achieve a half-baked product which may be unsafe, unfit, or not worthy, not roadworthy. So today in this session we'll try to cover topics and discussion around what is happening in the current scenario. Uh, I'll to make it things more interesting, let's keep it open-ended. Let's to begin with, the biggest pain point right now for OEMs, agencies, technology companies and suppliers is what?
I think it's a big question, but I'll take it. Um, I think we are, it's fortunate to have ARAI here on the panel. We are actually learning together. If you take, for example, new fuel systems like hydrogen, it's not exactly clear to us or to ARI what should be the most exhaustive list of tests. So we are taking global standards, we are looking at our own people to brainstorm, we are working with ARI, and then we come up with this super list of tests. Of course, the drawback of that is there is a whole bunch of tests to be done, but I think it also helps us because we have to be doubly sure with new technologies that nothing goes wrong. So that is something that's really working out nicely. Secondly, I think the converse of what I just said, which is after all this, we are still missing something, right? So when the vehicle goes out in the field, I mean, to be fair, it is new technology, so something else that you have not thought of, right? So that's what bites you in the end, the stuff that you could not put in the list, in spite of all the brain power and the joint activity and all that. So, but that's natural with any kind of new technology. There will be a few surprises, and fortunately, I think we have not had anything major or anything which had a safety concern type of surprise. So in that sense, the experience of working on testing and validation, especially with a lot of the new fuel technology, has really worked out well. And it's not just new fuels and technology, it's also things like new electronic systems, new smarts. Like we were just talking about ADAS while we were discussing outside, and ARAI has this data set of traffic data on Indian roads, which will be enormously useful in testing and validating an ADAS system, because most of the commercial ADAS systems, at least for commercial vehicles that we can buy, largely developed and tested in different environments, mostly abroad. There are very few that have Indian kind of testing data and how they will perform in Indian data. And do they identify unique things like potholes and speed breakers that don't have stripes on them, which are hard to identify even for a human being. So things like that, I think we are again co-evolving, which is a very interesting exercise for us.
So does that make or give Indian automotives an edge? Because now you're testing products in a very geographical, physical, environmental situation, which does not exist out of India, or which is much more demanding in India versus the rest of
Absolutely. I think if it survives in India, and if you even take the holy grail of the ADAS, the end stage of ADAS, which is autonomous driving, I think we should test it in India first, right? Because if it works, then you're absolutely safe in most other environments. And I was just at the ET Auto conference last Thursday, I think. And that topic of the panel was autonomous. And we were all talking about the same thing, that India should take the lead in terms of pilot testing autonomous for many, many different applications.
So, quickly bringing you, Manish, in the picture, Dr. Subramaniam mentioned about that huge data set that ARAI has compiled. So, can you, share some interesting anecdote, out of this, real world scenarios that you have found, and how are you working with OEMs and supplier ecosystem to ensure that we are able to accelerate adoption and rollout of ADAS?
Sure. Yeah. So as sir mentioned, we are working a lot on the data. The first question that you ask, how is it difficult to now to validate these systems? Now there are so many permutation and combination. Now if you look say from ADAS point of view, what to test, how to test is a big question mark, because use cases are infinite. Now if you and there is no experience, no knowledge, or no legacy to fall back and derive knowledge from. The technology itself is changing. We discussed since morning. We are discussing how technology itself is changing. So by the time you try to catch up with something, the industry has gone say 5 years back. Oh, sorry, 5 years forward. Now, if you look current scenario, previously we used to set up regulations, and then industry used to develop their product to meet those regulations. Now, if you see recent scenario, you are seeing now system in actual production vehicles, and now people are discussing how to regularize those things. So that is now paradigm shift we have seen in automotive industry, particularly from passenger car, where now new technologies first coming into market, and then we are talking about the certification and the regulation part of it. So that is something new that we are seeing. At the same time, there is, I think we were discussing now, there is a race to launch some new products quickly. So what it also doing is putting a pressure on the development part and on the testing part to validate as early as possible, because now we don't have time of, ideally I would like to test a new say feature for 2 years. I don't have that time, because in 2 years now, in months we are talking about developing all new vehicles. So these are all new challenges that we are also facing. And as sir mentioned that it's now we are also, it's our intent to work with industry. Parallelly, we are also looking or scanning the environment, trying to prepare ourselves for the new technologies. But with the industry support will require, we'll put some developmental effort with industry, and we're trying to move forward with the industry.
So, brother, quickly getting you in between, in between before I, go to Fez, you don't have that legacy. As startups, you don't have that bandwidth, you don't have that resources, you don't have that capex, and you also don't have the baggage. So, how difficult it is for you to introduce new technologies, because you start from a clean slate. Again, since you start from a clean slate, there is no precedence to it, there's no regulations. When I still remember when Ather was working on their electric scooter before it even hit the market, the overall size of electric two-wheelers industry, the high-speed category didn't even sell 10,000 units over the whole year, and that was around 14 or 15 different OEMs. And right now, I mean, things have drastically changed. So Ather, when Ather started working on electric, it was way much ahead of the policies and the standards that were set. So is it how difficult it is, because you're working without any precedence?
I'll carry it forward from where Dr. and Mr. Carley left. See, when you're looking at new fuel technologies, whether it is hydrogen or electric in our case, legacy does not exist. If you go back to the earlier fuel types, you had a lot of legacy, a lot of work was there, a lot of standards existed globally, which you could actually bring it to India, and then AIS, and you went forward. But whether it is EV, and I believe it will be similar in hydrogen, it's a great opportunity for India to actually innovate and put forward that this is the technology and this is the regulation. The way we at Ather look at a new fuel type, especially like electric, is a great opportunity for India to set this benchmark. We are a very large two-wheeler manufacturing country. We are a very large two-wheeler consumer as a market, and we are a fairly large export market. And this gives us an advantage to convert this into an EV. And let's start from the innovation part, because once you innovate, you are able to set standards. I'll give you an example, was this light speed, light electric combined charging system which Ather innovated. If you go back to the electric two-wheeler charging standards, they did not exist because the world had different problems to solve. While you had CHAdeMO and CCS2, the one that was available for the two-wheeler did not necessarily meet the market requirements or the environment which exists in India. So Ether actually went to the drawing board, innovated it, came out with what works in India, which is a combined charging system. Then we opened it up. BIS adopted it as a national standard. Today it's one of the national standard there, and you have the industry which is now adopting it. So I think this is a very clear example for the Indian electric vehicle ecosystem. And here I'm talking about both existing players and startups to actually do something new, work with organizations like ARI to see how we can bring that regulation and take it forward. And there are a lot of places. I think safety is one huge area where we can do. We have huge amount of, all the vehicles are connected, so there's a huge amount of data which is available to bring in safety mechanisms. We can possibly look at how do we make the vehicle consumer experience better. I think we look at it more as an opportunity to convert these innovations to take it. And the critical part is in EV, the innovation has to be done. So I think it's very clear for at least electric two-wheelers, I can speak for e-two-wheeler industry, either we innovate or there doesn't exist anything out there. So I think this is a great time, let's innovate, then bring the regulation in, make it into a standard, and then everyone benefits from that.
Fez, would you like to add something?
Hello. So I'll start with the data because a lot of data is being discussed right now. I mean, while we have a feeling that we have a lot of data, we also need to understand whether we have the right set of data. So the data that we are acquiring today is the speed of the vehicle. We are looking fuel injection, power, torque, all those parameters. But we are trying to solve an ADAS problem. So whether this data set is really good enough data set to solve the problem that we are trying to solve, our answer is it's not really adequate. While some data set is there, something can be utilized, but it is not adequate. Now, let's look at the whole validation process. So when we are doing the vehicle development, we broadly are 4 categories. We are looking at mechanical systems, we are looking at electrical systems, we are looking at electronics and control systems, and an interaction of all of these. And each of these have their own challenges. So for example, when we look at mechanical systems, we have new materials now, we have new processes now, and we really don't understand them as well as we used to understand traditional materials and traditional process. And the best way to handle those things are academia, because those are the people who do cutting edge research in terms of materials, in terms of processes and so on. If you look at electrical system, we have moved from 12 volt to 24 to 48. On the low voltage side, we have moved from maybe 300, 400 volt to 800 and even higher. And the challenges are very different that we need to figure out. Now, control systems are something which is very, very rapidly growing. And the challenges are enormous, not only from design development point of view, but also from the supply chain point of view, which is put enormous pressure. I'll give an example. So during COVID, a couple of companies came to us and they say we have a chipset shortage. So can you design this part without this chip? So now I have to replace X chip with a Y chip. And the moment you do that, it will require complete revalidation. And there's no budget for that. So from the investor perspective, if you look at, we have done all the validation cycle once. We have budget available just for one cycle. But supply can disrupt, tariff situation can disrupt your entire validation cycle, even for a proven product. And right now there is so much of pressure on the budget perspective that has to be done. One very neglected area is, we all develop vehicles, cars, two-wheelers, trucks, buses. And especially for the two-wheeler and passenger cars, we want to sell cars. So what is most important is perceived quality. And we have very little validation done on the perceived quality, which is the very core of the vehicle sale itself. And right now, we are trying to evolve scientific methods of how to do perceived quality checks that this vehicle will be a sellable vehicle. Those are challenges. Okay. So data set is something that needs to evolve. Also, there are industry standards that are coming. So there are now at least draft standards for cybersecurity. There are draft standards for AI safety. There are draft standards for what we call SOTIF. Those are available and they are growing, and I think we'll be following up with them.
Like one of the key areas of development is like, where we are talking about software. Like, earlier you had mechanical parts, more of mechanical parts. It was easier to understand the longevity, the materials, like, you could have some sense of predictability. Now there is more convergence of software. Has it made life easier for the automotive industry, because now it's easy to test, validate, since now you're like, you can look at simulation as a tool versus hardware, or has it make life much more difficult?
I think it has definitely made life easier. In a way, you're right, the complexity has gone up as a system, but that's bound to happen with technology, whether it's software or something else. I think complexity will go up and we have to be ready for that. But software has helped us in various stages. First, of course, the obvious one is simulations. A lot of the use cases, because we now have a lot of confidence in our simulations. There are many simulations that are validated. And we can now, even for exotic things like a crash test, we can get simulations not 100%, but almost there, right? And then maybe rather than doing 5 or 10 tests, you can do it in 2 tests, and then you can finish the job. Second one is in HIL, which is hardware in the loop, right? Which is a combination of hardware and software. There also, that is cutting down testing time significantly, because that at the controller level, right, you bring in various things in the loop, at least a few major controllers, and then you can write software for a variety of test cases, even a lot of edge cases, which means that cases that you almost will never expect, but it's just something you need to test for. Right, and ultimately you do vehicle in the loop, which means you have a stationary vehicle and you wire in that vehicle into a test console which simulates various conditions. So except for the fact that it's not loaded and running, everything else can be tested. So I think software has been a big boon for us, but the combination of software and hardware is what I would say is the real game changer. So given the advent of HIL and VIL, we have dramatically reduced testing time. We are also starting to use AI tools to smartly plan which tests we need to do, right? If you do a DOE and you have a full matrix of all combinations, that will take forever. But how do you hone in, if I have 100 possible conditions, but if I can just test 5 or 10 of them and that gives me an extrapolation to the balance 90, then that is another big blessing, right? So that is also something that we are trying, deployment of AI using historical data, but trying to extrapolate to see what are the smart ways to test.
Coming to AI, like, how has it made life easier now, since OEMs have a higher confidence on their product? So say 10 years down, 10 years before, or 2 decades before, did you see much more complex scenarios for OEMs to validate their findings, or where there were too many run-ins with AI and the testing agency?
No, as sir said, now we look at testing at even the GRA. If you look at their testing method at 3 levels. One is a complete simulation that starts from the software, then model in loop, then HIL, then driver in loop, then VIL kind of thing. Then the second level of testing will happen at a track level. You will see there are now different cities being set up globally, where they mimic the entire city conditions and do a controlled field testing. So say 80% of thing will happen purely at simulation level, some percent on test track, and the very last 5 or 10% will happen on actual road-like condition. If you are talking about say level 3 and up autonomy. Why this? Because if you look at sheer numbers where people say if you need to generate a confidence on say autonomous vehicle, you need to run at least for 1 billion kilometer. Practically it is impossible. How you are going to run 1 billion kilometer, gather that data. So this is simulation level approach that has been globally getting discussed. At ARA we are also preparing in the same lines. So we have also now got good HL kind of test benches. Near about Pune, we are also setting up our own smart city, we call it, around 20 acre, where we are creating a city-like conditions, and then industry can use them to run vehicle under control area. And then we are creating different scenarios virtually. So as I said, we can put actual vehicle, create the scenario synthetically with motion platforms, with the dummies, and then you do the most part validation under control condition, and the only last part then industry can do it on actual road. So that is how we are also progressing globally. One point regarding the software, the challenge or the question to us will be how to get hold on the source code part of it, because that is one gray area. Even see, I'm from a software engineer, so that is also I'm not able to see how the source code will come, or will it ever come at a certification body. HIL, MIL is okay, because for us it's a closed box testing. How the industry will be open to share their source code with us, because to have a complete validation of our software, we need to have a generic software test. There is a good testing, engineering is there, but how it will evolve in automotive is something, as a software engineer, I am also very keen to look at how it will get evolved. Because so far, nobody shares source code because that is their proprietary. So how that will come is the question.
So, Subroto, Faiz, both of you are the floor is yours.
See, on the software part, yes, it is going to be an interesting how industry will do. But here I believe there are examples in telecom, power, other sector, where the regulator does testing of equipment which goes into telecom networks or power grid. They undergo thorough security testing because they are part of critical infrastructure. So I think there are learnings which are there, not just in India, even abroad, which can be looked into, and obviously it has to be made relevant to the auto industry perspective, because here it is an individual vehicle when end of the day from a usage and not necessarily from a critical infrastructure. But yes, from a cyber security point of view, it's necessary to look at it. From the OTA and all, what we are seeing is that it is more and more it's going to become prevalent. We are seeing how it's getting deployed by leading auto companies globally. The trend has already started coming in here. The consumer expects the resolution to happen immediately. Please understand the consumer's expectation of the vehicle, when I'm looking at a product, is also evolving. 10 years back, it was purely looked at, say, a mechanical and an auto product. Today, at least when we interact with our consumer, it is somewhere between a mechanical device and a smartphone. The EV is somewhere there. So consumers' expectation of addressing, say, a issue in the vehicle, let's say a bug or something, was also equal. You can't say, bring the vehicle to the dealership, come 2 weeks later, then I'll fix it. I think the consumer believes that, there are faster ways to do it. And thanks to, information, the speed at which it percolates on internet and more so in social media, thanks to more AI coming in, the consumer is far more aware of how to fix that problem. So I think it's also incumbent on the industry from a skill perspective that we will have to do the skill upgradation of our people, not just in the factory, but in the service centers. Same with, testing and certification agencies to bring that capacity building up to address this newer, technology. I'm not talking about fuel technologies, but things like OTA, ADAS and all. And that's where we believe the consumer expectation will also drive this change on that part. And that's where we will have to come out with mechanism which will give comfort to the regulator in terms of confidence that yes, this vehicle is safe, roadworthy enough to be released on the road. At the same time, address the industry's requirement of able to quickly turn around and launch the vehicle.
First, before you share your thoughts, just to add on to this, very interesting point, consumer demand, global awareness, because now consumers are much more demanding because they are aware about what's available globally. They are not restricting themselves locally or what's available in domestic market. So as a result, OEMs are like, relying more and more to their tier one suppliers, to their software suppliers, because now, and for the suppliers, it becomes a challenge. You have to be one step ahead of what the consumer may demand. So, like, how does you?
Sure. I would like to differentiate a little bit between Indian consumers and global consumers. So while Indian consumers are now getting aware of ADAS and features and everything they're demanding, but global consumers are not demanding because they are already at the cutting edge, right? So they are being driven by the regulatory compliance or by the initiatives of tier ones and tier twos and so on. Now, one thing that is often said in such forums that software has become very complex, or major part of the vehicle is software. I think major part of the vehicle is still the vehicle. So it's just that we are not aware. So the kind of work that is being done in suspension system, the kind of work that is being in tire industry. I mean, you look at the tires which can run up to 360 km per hour or 400 km per hour, the kind of complexity that goes into is just enormous. We look at the braking system innovations, we look at, for example, material innovation, the body in white, the plastics, the recyclability. It's just that possibly they are not blowing their trumpet enough. The second aspect of software development is why it seems complex is, there are a lot of people my age here, and we'll remember when Windows 95 came and when MS Office came. It used to come in 20 floppies. 1.4 MB floppies, and 20 floppies means it is 30 MB or 40 MB data. And even today we use MS Office and we use only those functionalities. There is nothing extra we use, but of 16 GB laptop hangs 3 times. It's the same software that we are using, and today a 16 GB, 8 GB hard laptop is not sufficient. The reason being, if you look at the mechanical work, there is a mechanical engineer doing that work. So if you look at body in white, who's designing mechanical? You look at suspension, there is a mechanical engineer. Look at wiring harness, there is an electrical engineer. Software, everybody is doing software. If you look at suspension system, you go to an OEM, there will be a team of 10 people who are doing suspension. They are close-knit, they understand the requirement, they understand the customer, they understand the product, they designed it. Software, 800 people are designing the software for autonomous, and they just know one part of it. There are very few people who really know everything. So if you actually compare the complexity of what the MS Office we use today, which is a couple of GBs, it can be achieved in a couple of MBs. It can be done. And that's where the AI comes into picture. So if you look at some of the codes that are generated by AI, they are very, very efficient codes. So what people used to write in months, AI can write in a day or in an hour or as a click of a button. The second thing is, there are challenges. Of course, new things are coming and there are challenges, but can we work from other industry? For example, we are talking of cybersecurity. Now, cybersecurity to a bank or finance institution is no different from cybersecurity from an automotive. I mean, not from the implementation point of view, but the way they are attacked. The attack mechanism to a mobile phone, to a laptop, to a bank is same. Now the same methods will be used, nobody is going to put a new method. I mean, people will say we'll hack ECU, we'll hack steering system and brake system. But the attack mechanism will remain same. So can't we learn how the bank have made themselves safe and we adopt those technologies here? So AI is going to play a very large role, and just let me give an example of the software, how it is. So for example, we talk about the autonomous emergency braking system. There is a hard-coded software there. And the software does is it calculates where the object is, how much distance it is, what is time to collide, and based on the time to collide, it will calculate whether I have to do hard braking or I have to soft braking. Now let's say instead of that, you put an AI system there. An AI system is now able to evaluate in real time. Of course, there is a high compute. An AI system is able to say that I can actually do a lane change. There's a possibility of doing a lane change. So then you hand over this to an AI system, and it can write a beautiful code there. So those are the things that are going to come. This software complexity possibly will get simplified. We are looking at new architecture, Ethernet-based architecture, centralized architectures. And hopefully those things will get much much simplified as we progress. We are still learning.
So this data, this AI, who holds it? Is the Indian auto industry ready to share? Is that kind of conversations already happening? Because because if now software becomes if software is the differentiator, right? Like, do you see more collaborations not turning out, panning out?
Uh, I mean, I definitely see more collaboration happening, but possibly by force. So what is happening is we invent something, we have developed software and we believe it's our core competence, let's give the software to us. But when you look at China, they are already 10 years ahead of you. So your software is actually obsolete. You believe it's a great IP, but it is not. So everybody is realizing that unless we collaborate, we are not going to be very successful. So I think it will be forced upon us or thrust upon us to collaborate because everybody has a cost pressure. Today we have a product, you have to recover all your investment in 5 years. You don't have 20 years to recover those. New products are coming, you don't know whether you are going to sell the same car for 10 years or 5 years or 4 years. So the only way to go to cost down is collaborate. We do small pieces where we are good at and help each other.
So, I wouldn't say collaboration is always a good thing. There are times when it makes sense and times when it doesn't. I'll just give you a quick example. So we were developing a prognostics tool, which prognostics meaning we wanted to predict failure before it happens, right? And in our trucks, the biggest failure point is the clutch. Why? Because it is kind of designed like that. The clutch is supposed to be the fuse in the system. So if the vehicle is abused, the vehicle is overloaded, we want the clutch to fail first, therefore protecting other things. But then we want to also track clutch abuse and then extrapolate that data to see when it will fail. In other words, we want to tell our customers, next week your clutch is going to fail. You don't want to be stranded in the middle of the highway when it fails. So please do something about it now. So what we did was we found this data science company and we outsourced it to them. We gave them data. We said this is what we wanted to achieve. And they miserably failed. They could not predict to any degree of accuracy. For a day or two, we were also a little confused, right? Because they had a very good track record and they still failed, right? Then we kind of took a step back and we realized that the problem is in the word data science. So to me, there is data and there is science. And a lot of people who call themselves data science are only doing data. They're not necessarily doing enough science, which means they're only looking at patterns in the data, right? And some problems can't be solved purely by looking at correlations, which is statistics and statistics in a glorified form with some AI on top of it. I don't think you can do it. And this was actually a prime example, right? So we took the problem back because we had the experts who would understand the ins and outs of how a clutch works, what material goes into it, what is the physics behind how those materials wear out. So we included a lot of the science on how a clutch fails into that data model, right? And that combination of data and science is actually what worked wonders. So a lot of things like that, we realized that collaboration is not necessarily the answer. Just giving people data is not going to suffice, right? They also need to know the domain. And that combination, and unfortunately, a lot of the people who know the domain don't know enough of the data analysis part. So you need that combo to strike gold.
So basically, in-house development will always have an edge, given that you understand your product better than what you outsource it to.
I wouldn't say always. There are some use cases where you can outsource, but yeah, I mean, in this case, we actually burnt our fingers.
And just to add, it's collaboration of the right people. So collaboration doesn't mean you collaborate with anyone, but it's just the collaboration of the right people. I mean, people who know their stuff. For example, today, if you want to collaborate anybody in battery technologies, I think Chinese are the best. You want to collaborate anybody in infotainment system, they are the best. You want to collaborate something in the fit, form and function, Italians are the best. I mean, nobody comes close in fit, function, the look, the perceived quality.
Infotainment is a case in point because I don't think we have internal expertise on infotainment. So we would want to outsource.
So what about use cases? Like, Indian consumers are much more demanding and much more abusive when it comes to the way people operate their machines. And it depends on geography to geography. You go to the southern region, you see much more of a calmer version of people using the road, driving, riding sense. You go towards the northern side, you see a much more aggressive style. So now this vehicles, the same vehicles, operate in different environments and different conditions, both external, internal, and consumer oriented. So how do you test, or like, how do you predict all of this? Because again, a consumer left stranded in south will not, like, take it on himself, him or herself, that it is my fault. They will always blame the product.
There's no universal answer to this, but for sure, the electronics, the sensors, the data, and the associated analytics are helping us capture these conditions. So if somebody comes to us with a warranty claim, we are now armed with data, right? I mean, obviously, as a customer, we will do whatever it takes to help them and even go overboard to help them. But then if something has been clearly abused, I think the presence of these apps, if you will, right? I mean, again, if you take clutch as an example, because I just talked about it, if I have a piece of software running on the vehicle which is recording the sum total abuse of the clutch that the clutch has gone through in its lifetime, then I will be able to have a meaningful discussion with the customer, right? And I want to go one step further, because if this customer is seeing this kind of failure again and again, I want to modify the driver behavior by using the same software to give warnings, right? For example, my car gives me an indication of real-time mileage. So there is an instantaneous mileage it gives me, which means if I hit the brake, I'll see the mileage drop. If I do a harsh braking. If I do a harsh acceleration, I'll see the mileage drop. If I drive smoothly, I will instantly see the mileage go up. So at those failure points, at those abuse points, we want to give that kind of real-time indication. That's the dream, right? And we're not far from that. We actually can do a lot of that right now.
So what about developed markets? Coming to you, Manish, India was lagging behind when it came to emission norms. We were one of the late adopters compared to Europe from BS3, BS4, and then we directly switched to BS6. And going forward, it doesn't seem that BS6 is going to be the final stoppage where you've got EVs or alternative energy vehicles coming in. So there is still a lot more to say: diesel, petrol, CNG, LNG, and I don't know, the different fuel types. So now, does ARI work closely, or how do you ensure that you are able to meet the demands of not the Indian consumers, because now OEMs from India are also looking at export in a big way and developed markets per se. So is the Indian agencies upgrading themselves in a big manner, or do we still rely on external or international agencies?
No, I think in India we have a very good setup for the regulation formation. We call it to different AISC committees. So there is a huge, a well-defined mechanism exists since long in India to formulate regulation. ARI acts as a main secretariat in this process, but the process is handled by everybody, industry, government, and other regulatory bodies apart from ARI. So there is a well-defined mechanism already exists. If you look at even today also, there are different standards being discussed. There are different, what we call as AISC committees are already set up, not only for the existing subjects, ADAS, but in future, even till autonomous also, there are now committees being set up. We track global development. So we are also part of that global bodies who discuss, and then whenever there is applicable regulation, it is brought to India. So there is a well-defined mechanism that way from the certification point of view. From the data, like what has getting discussed, I will also share our learning. I agree with Dr. Subramaniam. See, data should be looked at, it's a data and science. That also is our hard learning because data generation is very easy. Now I'm running a vehicle with multiple sensor. After 8-hour shift, I am generating something like 4 petabytes of data, multiple cameras, radar. Now, if I have to look that data my entire career, I will retire only for just I keep looking at that data. but somebody needs to harness that data, knowledge. And we tried with the typical, say, data scientist people initially. They have their own way, as sir said. They will look at from a software, from the statistics, but that is not going to work. Because what you need is meaningful insights of that data. What we are trying to do for our problem statement is come up with the India-specific behavior. For that, you need an expert who understands what that behavior actually means, who understands automobile, who understands driving behavior, who understands driver psychology, and only those people will be able to extract that data. Where probably AI and ML tool will help is because they also can't go through that data. It's highly impossible for one human to look at those recordings. What also we are trying to bring AI and ML component, the software will probably try to detect some edge cases by itself. Those kind of knowledge, those kind of technology exist. So software will do the 80% or 90% filtering, but the rest 10% where actually a human element has to be there. So we also understood after putting a lot of efforts and lot of, that data and science are different, and data scientist is somebody is different. It's not a pure software people, and by doing some degree, you will not become a data scientist. That is our learning. And then from the collaboration, what we are also trying to do at our learning that data creation is easy, consumption is difficult, and doing 1% it is impossible task. The kind of efforts ARA has put for last 4 to 5 years, we know how much it costs, what it takes to run a vehicle across India, across different seasons. It is not an easy job. So there is a thought by our management to have a consortium. We will be soon reaching out to industry where ARA can act as a central body of that consortium, and then the consortium generates that data and consortium consumes that data. Then you are spreading out effort all over industry, and then entire industry can benefit. For that, yes, we need to be more open-minded. So we need to be able to share data, share knowledge across. The idea is to then boost this technological, because if you see this kind of mechanism easily work in Europe and America. They have these consortiums, industry, government, research institute, educational institute. I say we need also to adopt this kind of culture in India also, because that will help across all stakeholders.
Faiz and Subroto.
All right. So one challenge that we have been working with data for quite some time is if you know what you're looking for in the data, possibly we can go on a path which can find an answer. But many times what we have seen is we don't know what we are looking for. And there are traditional methods of data science. So as Dr. Subra said, that they'll just apply the same methods, and the same methods do not work. Okay, because what you're looking for. So for example, data science, I think it has matured in consumer sciences. So Amazon know what you're going to order, when, and what to display. Logistics companies, how to optimize logistics. It has really worked, and data science has done a lot of brilliant work. So what has happened is when these companies have looked at those data, similarly credit card companies, they have studied your pattern of your behavior when you are spending, how you are spending. Now, there are certain methods in those industries, and when we go to data science people, they adopt the same method, and those same methods cannot work. And we were in an Amazon Web Services seminar on AI and data sciences, and they say that in engineering, till date, there is no use case globally, not in India. Globally, we have not been able to find out how to use data and how to optimize and how to implement AI in engineering. We are doing a lot of automation, but automation is not AI. Okay, we are also getting confused many times that automation is AI. Now, coming back to the validation that we are discussing today, the challenge is we exactly don't know how to validate and what to validate. The question is what to validate. And typically our validation has been that we first write down the test cases based on the physics and engineering, and then you have a lot of experience and market. So with that market and experience, feedback, warranty claims, you refine your testing standards. But when you are designing something new, first time, you don't have any experience, you don't have any warranty, nothing is available. And at that point of time, only thing we can do is what we call something as a full factorial validation. That means on one part, one aspect, something can go wrong in 100 ways. Another part, another 100 ways, another part, then you multiply 100 factorial, but that means you are doing billions of cases. And if you have to do billions of cases analysis to start with, there comes digital twin. So with a combination of AI, ML, digital twin, possibly we can narrow down. Again, there is no substitute to physical testing, but we can minimize that. And that's where we are trying to head to. When we'll be there, we don't know.
Subrata?
See, again, purely from a regulation perspective, we see with the amount of data that is getting collected today, at least in the EVs, electric two-wheelers, in our case, all the vehicles are connected, so we know the driving pattern, usage and all. A lot of innovations can be built on top of it. Vehicle safety, driving safety is very clearly that. How do you help the consumer to get a better value for the vehicle, especially from their driving behavior in terms of, say, second sale, or in terms of what should be the renewal, insurance renewal premium is a very classic example, where if laws permit, I'm sure it's only a matter of time. Today, irrespective of driving behavior, both of us pay the same, but tomorrow if you drive, you have a good driving behavior and I have a poor driving behavior, you shouldn't be penalized for me because somewhere it's getting, you're averaging it out. I think, so there are lot of options where we can do that. Second, on the vehicle engineering part of it, again, we believe that innovations which are coming in, can we work very closely with the regulator or testing certifying agencies to get those regulations up. I think that is an area where we'll have to move much faster than what it is today. The response time, because please understand the innovation pace is much faster today than the pace of regulation. You don't want a scenario where there are multiple generations of the technology ahead, but regulation is almost catching up. I don't think it is good there, and there is an opportunity for India to step up and not necessarily look at either the west or the east and say, okay, let a regulation come and then we will regulate. I think we will have to put the step forward. It's going to be a difficult process, but I think that we'll have to start where once the innovation comes out of India, let's see how we put forward the regulation in and then goes, because it actually helps the industry there. And India then becomes a net contributor to this rather than a consumer. Last area where I want to leave thought is, I see the timer there, is on the capacity building. I think that's very clearly we are seeing. I heard what Fayez said, but what we are seeing is that you will have a multiple stream of technologies, experts who are now coming into the domain. The way they look at an issue is quite different, and I think here I agree with them. The way, say, a mechanical engineer stream looks at a vehicle and let's say a software stream looks at a problem are fundamentally different. But when you're looking at a vehicle as an end product or an output, but you will have a software which is almost like a version release which goes in, and then you will have a physical mechanical component which goes into the vehicle. How do you get all of them to work in a synergy manner and look at that problem? I think that is something that more and more needs to be done, and that will need for capacity building both within the industry and also with the various certification agencies so that we are able to address that.
Ladies and gentlemen, we have some time for open Q&A with the audience. If anyone has any questions, could you kindly raise your hands so that we can take your questions for the panelists? Any questions from the audience, or we have last 10 minutes for the panel discussion?
Okay, so while the question comes, I'll just add a little bit to what Subrata said. So while we are capturing a lot of data, there is one issue that one data does not fit all. So for example, if you take an electric drive unit, the OEM is capturing data, they are capturing current, they are capturing voltage, they are capturing temperature, couple of other parameters. And it will help them optimize the energy management, cooling management and those things. But if you look at the motor manufacturer, this data is somewhat useful, it's not really useful. So for a motor manufacturer, what they would like to capture is how the flux is behaving inside. and that data is not being captured. How the bearings are behaving, that data is not being captured. How the transients are in the system, that data is not being captured. So when a tier 1 is capturing that data, he is only capturing those things in testing, and which are limited in nature. OEM is not capturing the data. So if we could evolve in a way that we can capture data for the industry overall, I mean, that will be very helpful. Otherwise the data is limited, it is limited for the purpose for who is capturing. I mean, even we have seen in industry that data you capture for one department cannot be used by other department.
But again, like, coming to the same question, do OEMs currently have that luxury of testing their vehicles for so long to capture the data, to keep perfecting the vehicles when the market is dynamically shifting? I mean,
No, it's not the question of long, it's the breadth.
No, but that's what I was coming to. Like, consumers are demanding products, and every time a new product hits the market, the competitors are forced to further accelerate their product development, because you cannot survive in the market for, like, so long without having a product that can either compete with your competitors or exceed the expectation.
Yeah, I agree. I mean, I think what I'm saying is complementary to what Faiz is saying. It probably answers your last question. There are multiple situations we are facing where we can't do testing and validation to the full extent, and we don't have a proper simulation either. And even if I had a simulation, I wouldn't believe it, because there's no validation, right? I'll tell you a very simple use case, and you can imagine many other cases. So if you take EV, for instance, let's say I have a battery pack and I give a warranty for it. Today, I can give a warranty purely based on what my battery pack supplier gives me. So it's a back-to-back warranty. But let's say tomorrow, I do an enhancement. I either design my own incremental change. And why do we do that? Because if you take like the top two facets of a battery pack, one is how many cycles, how long it lives. Another is how fast you can charge it. So if you just take those two, and if you do some tweaks at a pack level to achieve, let's say, a better life or a better fast charge or both, then how do I test it? Today, a battery runs, at least for a commercial vehicle, we rate it to 4,000-5,000 cycles. And if I tweak it to, let's say, to go to 6,000, 7,000, 8,000 cycles, all I have is a hunch it'll work. Because however fast I test it, I can't test, I mean, the best I can do is 1,000 cycles a year at a pack level, which means I need several years to get to 6,000, 7,000 cycles. And there is no proper model. I mean, if any of you here have one, please share it with me, but I can't find one, right? Which models, if I give a particular charge-discharge cycle, it models what is happening at the chemistry level inside the pack, inside the cell, and therefore models failure modes, and therefore gives me a life. Or is there even a model saying that if I test one cell out of the pack for 100 cycles, 200 cycles, can it extrapolate a life up to several thousand cycles in a field condition? There is no model today that I can believe. Right, and this is a very simple use case, a use case of giving warranty on a battery for an EV. And there's a lot of guesswork. I'm just hoping that my battery vendor who I'm buying from today has tested it for years and years, so he actually has data. But if I make even a small change, I have no way of testing it because my cycle is short and I have to give the enhanced battery. I'm not going to wait 5 years, 7 years to deploy that enhanced battery in the field. I'll probably go out on a limb and take a risk and do something, right? And this is just for battery. I mean, for pretty much every new aggregate, right? There are use cases we are seeing where we are not able to test it and we are not able to meaningfully simulate it, right? So in all those cases, there is a team of people, so-called experts. We give the best judgment we can from the data that we are seeing, from the science behind that data. That's the best we can do.
Correct. And like, in the paucity of time, we'll just last parting thoughts. Top three trends that you see impacting the automotive industry, especially when it comes to testing and validation?
Start from there.
Let's start with Subrata.
New features, for sure. Innovation in terms of connectivity and software features which are seeing that. And specifically Indian context, I'll add the issue of safety, especially how, because all said and done, we have a notorious track record in terms of accidents. And I think we have now ability of connected vehicle to see how we can put that to use to ensure that to minimize the number of deaths and accidents on the Indian two-wheelers.
So just to like clarify, do you still was it in particular order, or like safety still is not amongst the top choices
No,
of a
if
consumer?
you ask me, safety is the number one.
Is it
But I was
is it
seeing
improved,
more
right?
from the consumer side of it.
Right.
So consumer demands feature, but if you say, for example, helmet, we are mandated to give helmet, but they don't wear.
Correct.
So we have to constantly educate them. Possibly every time he starts a vehicle, can you give him an alert, wear the helmet? So, but that is there. But I was seeing more from the consumer side. He wants features. He wants more connected and newer things in the vehicle. And obviously, from an industry side, if you ask me, across the OEMs, I can assure you, safety in the two-wheeler industry is today the topmost priority area.
Faiz?
In my view, three things that are happening right now in terms of validation. One is there is a definite emergence on digital twin. There's a lot of focus on getting the digital twin, make it more reliable by feeding more data and more instances and other things. So that's definitely happening right now, and it will improve in future. Also, there is a lot of emphasis. The second thing is incremental testing. So, I mean, we are not doing new things completely. I mean, if you talk about battery, it has been there for a decade or so. We are talking about DC-DC converter, it has been there. So now you make small changes. You move from 400 volt to 600 volt, or maybe move from X current to Y current. So there's a lot of focus right now not to do all over again everything, but to do incremental test. And that's why people are trying to save cost, time, and get faster to market. And third thing is about multidisciplinary testing. So instead of testing just one aspect in one lab, there is emphasis on equipments which can test lot many things together. So test multiple aspects of the product together so that we are able to save time as well as cost. Those are the three things.
Manish?
So for me, three trends we could see in the testing. First is the simulation-based testing. Even I think right now it is not mandatory, but going down the future, maybe regulation will also have a lot of simulation-based testing. Second trend we are seeing with standards like the functional safety or SOTIF, it will be more also process-oriented. I think with cyber security also, it's not the product, but also the process that will get scrutinized, and that we need to demonstrate whether we are following that process also. So it will not be only a product-oriented testing or the certification. Third thing, I think with process will also will be the traceability part, where we need to now see the entire traceability proof also. So I think those three trends will come into future.
I think they said it all. I'll just add one or two. We are focusing on desperately trying to reduce the number of tests we do. So first time right is a big slogan. It's still a dream, but it's a slogan. Which means sharpening the simulation skills, sharpening the agile skills, getting more and more confidence without validating every single thing, right? So that's pretty much what I had to add, and I think we've covered most of the other topics in testing and validation. But at the end of it, we are still seeing, after all this, we are still seeing an explosion in testing requirements, which is, I think, the reason ARAI is gearing up, GARC is gearing up, ICAT is gearing up. And I mean, there are just enough regulations and enough variants of vehicles. There is, I mean, emissions, there is noise, there is even the basic items that you would think are obvious. There are better and better regulations. So we have to keep up with the improved old regulations, and we have to keep up with the new regulations, like what is coming in ADAS and safety and all that.
So, ladies and gentlemen, with that, we conclude the panel discussion on testing and validation, and we'll be taking a short tea break. I'll request all the panelists to please join me for a quick photo op followed by certificates.